Here's the midterm review for Algebra 1. All right, we'll go over a couple of the problems. Please make sure to skip forward through the ones that you already know. You can go back to the ones that you don't remember or don't know or need to review again. I'll do only a couple of problems in each. I'm not going to do all of them, so you can practice. Remember, the answers are in the back for you. All right, if you're ready. So we're going to do 1 and 2. Let's try 1 and, or 2 and, I'm sorry, 2 and 4. Only because this one right here, this was originally y equals 0, and y equals 0 is actually just the line that goes, nope, sorry, y equals 0, that's x equals 0. Y equals 0 is the one that goes just on the x-axis, but it's not that interesting. Okay, and that's just a special case. If y was just to equal 1, it would just be right here. This is where y is equal to 1. It would just be a horizontal line. So here we go. Again, we're always starting at the y-intercept. I'll try to color coordinate here. So the y-intercept we're going to make blue. So it's going to be right here. This is the y-intercept. So always the number that's by itself is where we start. So we're going to go on the y-axis to -4 and draw a point there, and that's where it starts. All right, and then our slope can be determined by the number in front of the x. Here's where we like to have fractions. So we're going to just turn that into fractions. So that's going to be 3 over 1. And why is it 3 over 1? Because 3 divided by 1 is 3. So those are equivalent. And so again, this is going to tell us, remember it's rise over run. It's right over here, rise over run. That kind of helps us to remember what to do first. So the rise part for the 3, that's either the up or the down. Either apparently can rise up or rise down. So it's not left or right. So this is going to be 3 up because it's positive. And a run is going to be, what is it called? The left and the right. And that's going to be 1, it's positive 1, so it's 1 right. Okay, so from, again, the y-intercept, not from the origin. Some people just do it from the origin, and that would be incorrect. It's always our y-intercept. That's our starting point. And then we're going to go 3 up to 3, and then 1 to the right. That's the next point on the line. Think of it like steps. We're going to go up 3, 1, 2, 3, and then to the right 1. All right, and 1, 2, 3 to the right 1. I like to do it all the way across the graph, the coordinate plane, so I can see how to make my straight line much better. I would do at least 3 points, or you can just do like what I did and do all of them. If you want to go the exact opposite way, it would be 3 down and then 1 to the left. So 3 down, 1 to the left. Obviously, I run out of the grid, so I'm not going to do that one. And now we're going to draw our line. Okay, and I noticed that there are some people who don't really know how to do that. I always put my pen down on one of the points, put my ruler against it, kind of line it up to where I think it should go, and then I make it go up this way like this, and then I'm gonna go put my pen on the another point and kind of readjust it, and I go back to my original just to make sure I got it, and now I draw the line. Okay, so it goes straight through, just like that. Could have done a little better job, but it's pretty okay. But that's the basic, start with 1 point, line up, push against the pen with your ruler, and then adjust it, go to another point, and make sure you're adjusting your ruler, and go back to your original, and then draw your line. Do that to be a little more accurate. I notice some people don't really think to do that, or they'll do this right here. And if you put your pen like this, then you're going to go under your ruler as opposed to, making that straight line. That's why it's usually not straight when you're drawing with a ruler. All right, so let's try this one right here. Again, we're going to start with the y-intercept, which is the number that's by itself, which is this +1 right here. Again, y-intercept. So on the y-axis, that's why it's called the y-intercept, so +1. And then we're going to go with the slope. Here it's already written as a fraction, but notice we have a negative here, right? I'm going to just put it right over here. So again, the negative either goes to the top or the bottom. It can't go to both, okay, because there's only one, right? So you need to choose. It doesn't matter. I usually put it on the top. You could put it on the bottom. It doesn't matter, as long as it only goes to one side, either the top or the bottom. So -2 over 5. And again, that would be -2, remember it's the rise over the run, so -2 is down 2, so it's going to go down. And then the 5 is going to go to the right because that one's positive. All right. And so from the y-intercept, we're going to go down 2, 1, 2, and then 5 to the right. 1, 2, 3, 4, 5. All right. I can't go any further, so I'm going to just do one more point on the other side. So we'll go to the exact opposite. So that'll be 2 up, because that's the opposite of down, and then 5 to the left. So 2 up, and then 5 to the left. And there's my other point. It should line right up like that. So if you made the mistake of going 2 up, but then 5 right, 2 up, 5 right, notice it does not make a straight line, and you're like, ooh, something's wrong. Okay, these should always make you a straight line. Okay, and so again, we're going to draw our line. My point right there, and then let's see. There we go. Remember to put the arrows on there so that you are indicating that these lines do go on forever. We need to show that. That'll be especially important in geometry. All right, so please practice that part. We're going to go on to the next one where it says, write the slope-intercept form of the equation of the line. Okay, so notice that we're already given the line. We just need to do it. I didn't check all the things here. All right, so we're going to do number 5. And if I take a look at, so I'm going to I like to find the y-intercept. So that's my y-intercept right there, easy to find. And so that's one of my points to find the slope. Remember the rise over the run. And I'm trying to look for another point that's close. And so if you think, oh, maybe it's 2 over 1, try it one more time, 1, 2, and then over 1. And if you notice, I don't end up on the line, which means that's not the correct slope. So let's take a look here. Ooh, this is my other point right here. Looks like. Okay. Unfortunately, I can't check that because there's no other, but there's honestly no other point that would work. So, actually, so my y-intercept, which equals -3. So I'm going to put -3. And then so y equals, and then I know there's the slope and then x. So I'm going to figure out what that slope is. I used purple. So I'm going to just go, I usually like to start on the bottom one, figure out how much I'm going up here. So I'm definitely going up. 1, 2, 3, 4, 5, 6, 7. So this is +7, right? Remember, don't count the point that you're already at. You're just counting the sides, right? So 1 box, 2 box, 3 box, 4 box, 5 box, 6 box, 7 box, okay? And then we're going to go across 1, 2, 3. And that's to the right, so that's +3. So that's going to be rise 7 over 3. Just like that. All right, and if you look at for number 6, again, I didn't check these ones. So remember, this is on the x-axis, so this is where x is always equal to -5. So in this case, this is just x equals -5. And just as a bonus, let me see if I can just write one for you. Let's go to 4. And we'll do another point, like this one, -2. This is just to practice, okay? So I don't take some of your other problems that you could have practiced. Okay. Oh, and maybe I should have gone the other way, like make it negative. Oh, well. All right, same thing again. Remember the y-intercept is right here at -4. So just go -4 like that. And we're going to go, now I'm going to go down 1, 2, 3, 4, 5, 6, still down 6. And then to the left, 2. That's -2. So it's going to be -6. So the slope is -6 over -2, which is going to be, it simplifies to 3, right? -6 divided by -2 is +3. And think about it, remember, it's 3 over 1. So let's just check that. So basically, remember, I go 3 up and 1 to the right to get it. So I'm going to go from here, 1, 2, 3 up and 1 to the right. And notice, I'm still on the line. 1, 2, 3 up, and 1 to the right. Yep, I'm doing it. That's the way it's supposed to go, right? So that's my slope. So it's 3x is so y is equal to 3x minus 4. Huh, you can't see that. 3x minus 4. Okay, dokes. All right. Trying. Okay, do you see that this is a little hard to see on there? We're trying to make the domain and range. We're trying to figure that out. So remember, the domain is talking about the x values, and the range is talking about the y values. So here's the domain. Notice there are no arrows, okay, no arrows. So it does not go on forever and ever. So there's a restriction here. So the domain is basically, we're going to make a like a square around this. Okay, so we're going to say, okay, how far left does it go? So like it goes as left as -3 on the x, right? That's as far as it goes. The graph doesn't go any further. And then how far right does it go? It goes all the way to 4. So these are the restrictions. Okay, we're kind of fencing it in. Okay, so it's from -3 to +4. So we're going to say from -3 is less than or equal to x, which is less than or equal to +4. All right, always a smaller one is on the left and the bigger one is on the right. X is in the middle, and we're going to go with less than or equal to. So these are always going to be less than signs. For our case, it's always going to be equal to, because yes, at 4 it can be what is it? A value, right? It can be, there is a point there. Okay. All right, for your range, let's go with orange. And this one is going to be the value of y. So if you look for range, what are the things that y can be? How low does it go? And if you look right here, it doesn't matter that this is in the middle of the graph. You're gonna, because that's as low as it goes. That's the lowest point. So it goes from +1 all the way up to +7. So 1 to 7. So 1 is less than or equal to y, which is less than or equal to 7. Okay, just like that. Okay, we've boxed it in. All right, we'll try that for one more. We'll try that for 11. So I'll go with, remember, since you can't see that very well in video land, that's the line right there. Sorry, it came out a little light. And we're going to start with domain again. So what are the values of x? So how low can this go? It goes all the way to 2. All the way to the right to 6. That's it. So domain is going to be from 2 less than or equal to x, which is less than or equal to 6. And then our range is going to be the y values. So that's going to be from 2 all the way to 4. So 2 to 4. That's not all the way, I guess, but from 2 to 4. Just like that. All right, again, some people think that the range is going to be like how high this the numbering goes. That would be incorrect. It's just going to be where the actual graph is, how high it would go. All right, and again, practice more. All right, so now we're at evaluating each function. So when we're evaluating these functions, we need to know, well, what the function is. So here's our function right here. And we also need to know what we're trying to evaluate. So it will give you something like this. So function notation, remember, w of x is just y. Okay, this is just like labeling it, right? We want to know, well, what kind of y? Well, this one is for the function w. Okay, and notice that this -10 is in the place of this x. So we want to know, what is the y equal to? What is the answer if x is equal to -10? All right, so we're going to plug in -10. So here we go. So w of x, or w of -10, is equal to, now wherever we see an x, we're going to put in a -10. So that would be -10 minus 2. Okay. Okay, and let me just get my highlighter here. So wherever this X is, that's where my X is right here. This should match. See, they should match. If they don't match, something went wrong. All right, and all we're going to do from here is just simplify the right-hand side. You do nothing with this. Remember, this is not W times 2, just W times negative 10 is what I meant to say, sorry. This is just W of negative 10. That's how we call it. All right, and so we're going to simplify the right-hand side. Negative 10 minus 2 is just negative 12. That's it. So W of negative 10, when X is negative 10, what is the answer? Negative 12. That's it. We'll try one more. If we have something like 15, we want to find W of 9. So, and again, we're going to put in 9 in where the T is. So W of, let me see if I could, and it's going to be 4 times whatever it is plus 4. This is going to be, so we're putting in 9, so W of 9 is equal to 4 times 9 plus 4. And here are our T's like that. That's what we're replacing. And then again, order of operations says we're going to multiply first. So 4 times 9, which is going to be 36, plus 4, so that's going to be 40. All right? So W of 9 is equal to 40. All right? All right, and it says for the next one, find the explicit formula. So remember there are two. It's going to be either arithmetic or geometric. Arithmetic we worked on more recently. Geometric is more the one that we did a long time ago. It's the exponential one. So let's take a look here. We're doing number 17. Things to remember that the arithmetic is going to be A1 plus D times n minus 1. This should look more familiar. Remember, A1 means that that's the first term. D is going to be our common difference. Running into the next one, sorry. So remember this, think of this as like adding and, well, we'll get to that in a bit, sorry. And then the next one is the geometric one. We're just going to signify that by saying G. So G of n is equal to G1 times the ratio, right? We call it ratio of n minus 1. Okay, to the n minus 1, I should say. And again, this is the ratio, common ratio. And this is, again, the first term. Okay, that's what that's going to look like. So first we need to determine, are we adding or subtracting? Adding or subtracting? And common ratio is going to be multiplying, dividing. So this is multiplying or dividing, I guess we can say. But common ratio is always represented with a with multiplication, right? Something to think about. Okay, so this is 5, and then negative 15, negative 35, negative 55. So you notice that these numbers are increasing, or not increasing, but decreasing by subtracting 20 every time. Or we can say adding negative 20 every time, right? So I know I'm going to be in the world of arithmetic sequences. Okay, and so again, we got our first term right. So it's going to be a sub n is equal to 5. That's our first term. And we're going down by 20 every time, so we're going to go minus 20 times n minus 1. This is how we can get any term we want. So let's say if we wanted the 100th term, right? We just plug in 100 for the n, and we just simplify it, just like how we would have done here, right? It's just written in a little bit different way. That's it. Okay, and then let's go down to 21, and I'm gonna take a look at this. I noticed that this goes big really fast, so I'm gonna think, ooh, I'm probably multiplying. And so from negative 2 to 10, how do I do that? And honestly, if you were gonna try and see, like add it or subtract it, negative 2 plus 12 would give me 10, but 10 plus 12 does not give me negative 50, so I know it would not be arithmetic. So here I'm multiplying by -5. So let's see if that works again. So here from 10 times -5 is -50. This works. Excellent. Another way to figure out the ratio, if you take one of the terms, like 10, divide that by the previous term, okay, not the one after, the previous term, -2. 10 divided by -2, it gives you a -5. So that's another way to do it if you could not figure that out. That's kind of the other way to do that. So let's try this out. So g sub n is equal to, remember it says our first term, which is -2. Got to know where we're starting, times the ratio, right? Our common ratio is -5, right? Don't forget to, I'm going to put this in parentheses because I'm trying to include that -5 as part of our common ratio. And then it's to the n minus 1. That's it. All right. That's all we got. All right, and let me just highlight a few things so you can kind of see where they are. We haven't done this one as much. So this is our first term, which is that right there, our first term. And let's go with this yellow. And right here, these guys right here, our common difference is this one. Oh, it's bleeding a little bit, but that's fine. Our common ratio right there. Okay, that's what those are. All right, moving on to the next ones. So given the explicit formula, determine the 52nd term. This is what I'm saying, right? So instead of having to just keep on doing this until we get to the 52nd term, because that's quite a bit, right? This is what n is equal to. N is equal to 52, okay? And so if you take a look at it, so we already have the explicit formula. Technically, we don't even need the sequence, but it's just a visual to kind of help us see what's going on. -18, then -38, -58, -78. So it looks like we're going down by 20s. Going down by 20s, starting at -18. So again, so we're going to just plug it, instead of n, we're plugging in 52. So this is like kind of like the function notation idea. So this is saying, oh, this is the 52nd term. So this can be -18 minus 20 times, again, n is 52 minus 1. Okay, everything else stays the same. It's not the same, it's not correct. All right, order of operations says to do the stuff in the parentheses first. So I'm going to copy everything else down until I get the parentheses. That's going to be 51. All right, again, we're going to multiply. Right, so this -18 minus 20 times 51 is going to be 100. It's more than 100. That'd be 10 and 2, 102, and then a 0 at the end. Okay, so I was trying to do that in my head. And then we're going to just subtract those two guys. So, but remember, this is negative, so we're getting just more negative. So this is just going to be -1038. So the 52nd term is -1038. I'm just going to go A52 is equal to -1038. See, good thing we didn't do that manually. That would have been sad days. All right. That's what we do. I'm going to do one down here. Let's see here. Let's do just 29. Okay, we're determining the 8th term. So this is n is equal to 8. Looks like we're in the geometric world. So again, we're starting at -2 and we're multiplying by 6. Right? So g of 6, sorry, not 6, of 8 is equal to -2 times 6 to the 8 minus 1. All right, 8 just goes in the place of n. And so g of 8 is equal to, we're going to do the what's in the exponent first. So that's 6 to the 7th power. All right, and we're going to, I don't know what the 6 to the 7th power is because that's quite a bit to do. So on your calculator, you are going to go type in 6. Right here, there's 6. And then this caret button right here, this little arrow looking thing, the caret button gives us the exponent. So to the 7th power. So that's what it should look like. 6 to the 7th power equals that huge number, 279,936. Okay, so it's going to be, again, -2 times 279,936. And now all we need to do is times that by -2. So don't delete that, don't erase that or clear that, just multiply. You just hit multiply. That just means the answer. So the previous answer, that's what it is, -2. Don't forget negative is down here, so -2. All right, so it looks like that. So the previous answer times -2 equals -559,872. So that would be -559,872. So I'm going to just write this nicer. So g of 8. So a g sub 8, which is going to be our 8th term, is equal to 559,872. Ta-da! Done, just like that. All right, let's take a look at number 34. Here we're just solving each equation. Basically solve for x, right? So let's try this out. I notice that I have some x's over here on the right-hand side of the equation. When I say side, I mean the right side of the equal sign, okay? The left side of the equal sign and the right side of the equal sign. Okay, so I know that I have 2x plus x. We're just going to group them together. So this is going to be -5 is equal to -2 plus 3x. So 2x plus x is 3x's. Okay, from here, we're going to try and get x by itself. So what we're going to do is we're going to we're basically undoing the order of operations. So we're going to get rid of this -2. So we're going to add 2 to both sides. Why do we add 2 to both sides? Because what's -2 plus 2? 0, right? Which means all I have left is that 3x, which is what I want. I want it to get x by itself, right? So -5 plus 2 is going to be -3. That just becomes 0, so all I have left is the 3x. If this was a -3x, then that would be -3x, okay? And then from here, 3 is multiplying with x. So how do we undo multiplying a 3? We divide 3. So we're going to divide 3 to both sides. We've got to keep that equal. Because of this equal sign, we have to do it to both sides. We've got to be fair. All right, and then this 3 divided by 3 is 1. Because if it was 0, that would be bad days. Because 0 times x is 0, and there's no more x. Now we've got to go look for it, right? So 3 divided by 3, that's 1. And what's 1 times x? X. All right, and so here we go. This is what we call canceling it out. -3 divided by 3 is -1 is equal to x. I like to rewrite it so that my x is on the left. Do you have to do that? No. I just like doing it, though. All right, so x is equal to -1. So if I were to plug the -1 back in here, it would work. Okay, you don't have to do this part necessarily, but let me just show you the check for it, right? Because, you know, just to see, like on a test, I like to know if I'm right or not, right? As much as I can. So we're going to ask, -5, is that equal to, that's why I have the question mark above it, -2 plus 2, and then instead of x, I'm going to put in -1. I'm going to see, does this really work? Plus, right, because all has a plus right there, -1. All right, and I'm just going to simplify the right-hand side. So -5 is equal to -2. -2 times -1 is -2, so -2, and that's just -1. Remember, plus negative is the same thing as a minus. And then I'm going to, oh, I still need my question mark here. So -2 minus 2 is -4, minus 1 is -5. So I get -5 is equal to -5. Yes, this checks out. I know I'm right. All right, unless I made a mistake there, but I didn't. So there we go. Happy days. That's how you solve for that. On the other side, let's do number 37. All right, we'll do 37 and 38. Call it a day. All right, let's take a look at this one right here. If you notice, there are 2 ways to get rid of these parentheses. All right, the first way is to just distribute. Most people distribute because that's usually the way it goes. There is like another alternate method. I noticed that the 110 is divisible by 5, so I can actually divide both sides by 5. Okay, I only do that when it goes in evenly, or else you're going to end up with fractions, and that's sad days for most people. Okay, so I'm going to show you first the distributive way, right? So 5 times -3x is -15x. We're multiplying. And then we're going to distribute the 5 with the 1. So 5 times 1 is, it's positive 1, is positive 5. All right? And then we're going to be like, that equals 110. And then from here, we're going to, again, just like how we did before, undo the plus 5, which is subtract 5 on both sides. And then we get, I'm going to just go with purple. So we have left negative 15x is equal to, that is going to be 105. And then how do we undo multiplying by negative 15? Divide by negative 15 on both sides. So x is equal to, not sure what that is, so we're going to try that on the calculator. So we've got to go 105, 105, and then divide that by negative 15. Remember, the negative is not this minus, it's this negative right here. Okay, and that's going to equal negative 7. There we go. So let me show you the other way just so that you can see what it looks like. So 5 parentheses negative x plus 1, negative 3x plus 1 is equal to 110. And so this time I am going to divide both sides first by 5. Right, so the 5's cancel out. So I have negative 3x plus 1. The reason why I like this way is because I have smaller numbers to deal with. Right, 5 goes into 11 2 times, remainder 1. 5 goes into 10 2 times. So that's 22. All right, so again, just like how we did before, but do you see how that's smaller numbers? So now I'm just subtracting 1. Same methods here, just smaller numbers. Equals to 21. And this one I can kind of do it in my head. Like negative 3 times what number will give me a 21? Negative 7. But algebraically, this is what you would do. You would divide both sides by negative 3. And x is, again, equal to negative 7. See? Same answer, different method. It's the same thing. Okay? So I would only use this if the other number on the other side is divisible by that number on the outside. All right? Okay, and I'm going to do number 38, and then you could practice the rest of them. Again, right here we have this, we have to distribute. I would not divide by 6 here, only because I would also have to divide by the negative 2. Negative 2 divided by negative 6, which is going to be 2 over 6, which is not something I want to deal with right now. So I'm going to just distribute this negative 6 first. So I'm going to copy everything else down. So negative 164 equals negative 2, because we did not do anything with those yet. Negative 6 times 4x is going to be negative 24x. All right, and negative 6, please make sure you're taking the whole, the negative as well. Negative 6 times negative 5 is positive 30. Negative times a negative, like those negatives undo each other. So I'm going to rewrite this. So I'm going to combine like terms here on the right-hand side. So we got the negative 2 and the plus 30. Both of them are just numbers. So we're going to add them together. So that's 28 minus 24x. All right. And just so that you know, this came from here. So we just combine. So this is what we call combining like terms. And then from here again, we're going to get rid of the number that's by itself because x is multiplying with the 24. So here we go. So again, to get rid of the 28, it's a positive 28, right? So we're going to have to subtract 28. Do not look behind it. It has no effect on what this 28 is. It's still a positive 28. So we're going to subtract 28 on both sides. And if you ever are in doubt, go 28 minus 28. Does that give you a 0? Yes. So that cancels out. And then we have left, that's going to be negative 100. It's 892. Okay, 192 is equal to, and what we have left here is, don't forget that negative 24x. Okay, and again, we're still multiplying by negative 24, so I'm going to divide by negative 24. And I get x is, oops, wrong color. I'm just going to put my x on the left hand. X on the left-hand side. I'm just going to switch it like I've done before. So again, we're going to go with negative 194. Nope, just kidding. 192 divide that by negative 24. I know that's going to be, I should get a positive answer because negative divided by negative, just like negative times a negative, is going to be positive. Equals 8. There we go. So if we were to plug 8 back into this equation, it will work. It's the only number that will work. No other number will work. It's a unique solution. All right, that's the end of the review. Study hard, do well, practice all the other ones. If you need more practice, please let me know. Have a good one.